I am so greatly delighted, and today we are going to focus on something very crucial, very important, that I want us to actually share and be able to have a clear understanding of what it all involves. And what I want to actually share with you today is the differences between short-sightedness and long-sightedness. And I actually got this question from my former candidates who did her Kenya Certificate of Secondary Education and is now in one of the best colleges training students in medical courses. I would first want to say this. Short-sightedness is a condition, and as well long-sightedness is a condition. So they are called eye defects. These eye defects, or what are just eye defects? Eye defects are structural changes to the eye structures that will make vision or seeing or perception of anything in the environment achieved with difficulty. And a good example, as I have actually mentioned, is what we call short-sightedness. In a layman's language, this can also be able to get referred to as myopia. Short-sightedness or myopia is a defect of the eye that makes seeing or perceiving objects in the environment achieved with difficulty. More specifically, those objects which are far from an individual. So, short-sightedness means light rays from a near object are correctly or well focused on the retina, while light rays from a far object are focused in front of the retina, forming a blurred image in the vitreous humor. I repeat, light rays from a near object are well or correctly or effectively focused on the retina, while light rays from a far object or light rays from an object far from the individual are actually able to converge in front of the retina in the vitreous humor, forming a blurred image. In other words, at the end of the day, anything that is near to the individual is well focused, while anything far from the individual is not able to get well focused on the retina. So this is called short-sightedness. From the word short, that means anything near to you is well focused. So we are what we call a short-sighted aspect. You can see what is near to you, but anything far from you is not well perceived. The image is formed in front of the retina in the vitreous humor. At the end of the day, a blurred image is formed, making perception of far objects achieved with difficulty. And of course, you can have this as an individual getting observed from far, and this can be your eyeball. Look at that. This can be your eyeball. Okay, this is your retina. This can be your lens. So we have these. These are the light rays from this object. These rays are able to converge. Look at this. So look at that. So this is the object getting observed. These are the light rays moving into the eye. This is our lens, and this is where we have what we call the convergence of light rays. This is our retina. We expect the image to be formed. So you can imagine we have what we call a blood image. Blood image. I told you this is in the vitreous humor. So this is the object under observation. These are the light rays moving from the object and entering the eye. They get refracted by both the cornea and the lens, and instead of these rays converging on the retina, they end up converging in front of the retina. Look at that. So this causes what we call short-sightedness. So this object is far from this individual. The rays from this object are converging in front of the retina in the vitreous humor, forming a blurred image. So at the end of the day, the observation of anything far from the individual cannot be well observed, cannot be well achieved. And the causes of this short-sightedness or myopia is too long an eyeball. If the eyeball is too long, then it means light rays may actually end up converging just before reaching the retina because the eyeball is long. So too long an eyeball can actually make the rays not converge in the retina but converge in front of the retina. That is one of the causes of short-sightedness. Or when the rays reach the lens has what you call a very high refractive power. Too much refractive power, highly refractive power of the lens can make the rays to converge before reaching the retina. So a refractive power of the lens, for example, when you talk about refraction in physics, it actually means the ratio of the speed of light in air with any other medium like water. So, and we gave an example of the refractive power of water with respect to air as being 1.33 something. You see, so the lens has a high refractive power, making the rays to converge in front of the retina and not on the retina. So those are the causes of what you call short-sightedness or myopia. Too long an eyeball will make the rays to end up converging before reaching the retina, or the high refractive power of the lens strongly refracting the lens. And when those lens moving rays from the object are actually able to get strongly refracted, then that means those rays may not reach the retina. They are strongly refracted in front of the retina and not on the surface of the retina. So how can we actually correct this condition? I will expect this to be my object as well. Okay. And I'll actually be able to put on what you call concave lens. Must have had a chance of getting this. So it's something new. So this is my concave lens. This is my eye. This is my strong lens, my long eyeball. So what happens? This is what happens. This is what happens. What happens. So you can just have a look at this and be able to understand what I'm trying to do. So when a concave lens, concave or diverging, when a concave lens or a diverging lens is put on in form of what we call the glasses, we always put on our eyes. They appear in front of our eyes. So when light from the object will reach this concave lens, the concave or diverging lens will diverge the rays. So when the rays are well diverged, on reaching the lens, they will get converged on the retina. Look at that. So the rays from the objects are able to get well diverged. So on reaching the concave lens, they diverge. They diverge. On diverging, they get well converged on the retina by the lens and the cornea. That is a remedy you can be able to actually have in as far as correcting this short-sightedness is concerned. Putting on a diverging or concave lens, they will diverge the rays from the object and they get well converged to the retina by the cornea, the lens, and the vitreous humor. That's all about short-sightedness. And maybe you want to actually talk about long-sightedness. It is also called hypermetropia. Hypermetropia. So short-sightedness or hypermetropia. This is also an eye defect where light rays from a far object are correctly focused on the retina, while light rays from a near object are focused behind the retina. I repeat, light rays from a far object are correctly focused on the retina, while light rays from a near object converge behind the retina. A good example can be this. This is an object. This is my lens. So when the rays reach here, so the light rays from an object on reaching into the eye, they don't converge on the retina. They converge behind the retina. So perception of anything near to you, if you are actually long-sighted, becomes difficult. Why? Because the rays of light from the object you're actually looking at enter the eye and they actually end up converging behind the retina and not on the retina. Causes: one, the eyeball is too short. So when the rays travel, they find themselves not converging on the retina and finally end up converging behind the retina. Or this lens is too weak in terms of its refractive power. So if the lens is too weak in terms of its refractive power, it may not converge those, it may not refract those rays to fall on the retina. So its weak refractive power will make the rays to actually end up converging behind the retina. So the eyeball is short, causing the rays to converge behind the retina, but the lens is too weak in terms of its refractive ability. So the rays end up becoming less refracted. So they end up meeting behind the retina. So perception of anything near to you becomes difficult. Now, what can you do? This is what you're supposed to do. So you can have what you call a converging lens. So what you call converging or convex lens. This is your eye, okay, short eyeball. We have what you call the lens here, which is weak. So it does the convergence, correct? Very good. So what happens? Because the lens has a poor or a weak refractive power and the eyeball is too short, then what happens? You'll actually put what we call a converging or convex lens. The lens converge the rays. On converging the rays will actually end up getting refracted onto the retina, focusing anything near to you if you are long-sighted. Thank you so much and let's meet in our next lesson.